Hey friends, Monodux here. Just wanted to spend a little bit of time exploring how to use the Behringer 960 and 962 with the ARP 2600 or the Behringer ARP 2600. I think these are an awesome pairing, as I've said in a previous video, but I wanted to go over some specifics because there are some unexpected connections that might need to be made to maximize this. So I'm going to start by talking about the internal oscillator, which is currently running and providing clock for the whole system, but we had to do some specific patching to make that work with the 2600. So let's talk about why that is. All right, so the voltage that comes out of the oscillator of the 960, which is an oscillator providing timing, that's a little bit weak for the 2600. So I'll just show you what it's like if I were to try to go straight in to the gate with that. So it's not really enough voltage to open the gate by itself, which is not a big problem because we can use our preamp down at the bottom to get the voltage we need. So basically all I've done is I'm taking the oscillator and running it into the preamp and then out from the preamp into the gates. And the setting that I have is the middle one. It's times 100, and I've just got it maxed out. So we'll take the oscillator output, run it into the preamp, and then run it into the gates, and everything will work fine. Now we've got enough power to open the gates, and we can use the internal oscillator. I've shown in a previous video how you can use an external clock source and plug it into the shift control, and that will link it up with other gear. So if you run MIDI to VCA, you can use that to sync up with your other gear. I was using the Arteria key step to do that, and it worked great. But if you want to use the internal oscillator, you can do some pretty wild things with this. So for today, I'm just going to do that. The oscillator has a frequency range and then a vernier to fine-tune that. So you may have noticed that goes into audio range, so this can actually be used as an oscillator, which is pretty crazy. So anyway, I want to talk about the basic setup here on the 2600, and then we'll look in detail with some things that we can do on the 960. So once I've got enough power to trigger my envelopes, the other thing to consider is getting control to my oscillators. For simplicity today, I'm just going to use oscillator number 2. Currently, I'm outputting from the top row A, directly into the FM control on oscillator 2, and that controls the pitches. And just for clarity, I'm running a triangle wave. Not too much going on, just so you can hear things really clearly, what's going on. Okay, so as far as the step sequencer goes, we've got 3 rows of 8. And what you can see is that we've got switches that turn on and off steps. So I'll just demonstrate that real quick. And if I turn it to stop, it'll just stay there and repeat. One of the things that makes this go is the fact that we have a final stage that is set to skip, so that just keeps going. And if I switch that to stop, it plays through the sequence once and then stops. not super useful for my purposes. So I'm just going to leave that on. Alright, so that's the basics of the steps. If you wanted to tune them without having a, a particular pitch quantizer handy, what I do is just open up my initial gain so I can hear what's going on. And then you can select which step you're on just by pressing the button. And then, of course, that same technique applies for rows 2 and 3. So, but if I turn that gain back down, then it's going to wait for gate signals to open. Okay, so that's the basics of how I would approach programming, putting in my pitches, using the steps. And now let's talk about the sequential switch, which is rather awesome. So in my previous video, you could see how you can connect all 3 rows of the sequencer to the switch. So let's just set that up real quick. First thing I'm doing actually is taking the output, instead of from a single row, I'm going to take the output from the 962. Which will give me outputs from any of the rows that are active. And I'm just going to connect all 3. Okay, so now I should have the same sound. If I just re-engage the oscillator. Let me move these cables down. If you can see it, number 1 is illuminated on the 962. And if I were to change, press another trigger. Now we're on row number 2. And if I press 3rd trigger, now we're on row 3. And it's as simple as that. If you want to manually control your progression, as I did in my previous jam with the 960, that's the simplest way to do it. So there's another really cool thing that you can do. Is you can use the outputs of these individual steps. So if I wanted to switch which row I'm on, I could do that pretty easily by sending a trigger from a step. So let's try that. Something to bear in mind is that the ins and outs refer to the beginning and end of the step. So if you want something to happen on step 5, you need it to happen at the end of step 5, which means it goes on that output. So I'm going to say step 5 right now I've got skipping. So I'm going to take the output from step 6 and run it into the shift. And the shift input is what changes which row you're on in the 962. So now every time we hit step 6, it's going to shift where we are on this sequential switch. Now, one of the things you may want to do with the sequential controller is use stages to jump back to other stages in the sequence, making a shorter pattern. So that won't be possible without a little bit of extra processing. So let me just show you what happens. If I take the output of stage 7 and run it into the input of stage 2, what doesn't seem to be working for us is that we do stop at 7, but we restart on 1 instead of 2. So that's not doing what we want it to do. Let's talk briefly about gates versus triggers. The good news is that this can be overcome with a little bit of processing. And the reason why this is necessary is because the 960 and 962 are functioning like the old Moog System 55, which uses both trigger and gate signals to accomplish various goals in the system. The difference is that a trigger is basically an inverted gate. A gate activates when the threshold is high and the voltage is high, and a trigger does just the opposite. So we can certainly do that on the 2600, and we can use our voltage processor to accomplish that because it includes inversions. So what I'm going to do is take my gate out from stage number 7, and I'm going to flip that voltage and turn it into a trigger. All right, so I've got it on the input of line number 1 on my voltage processor. And then I'm basically just going to take the inverted output of that and run it back in. And let's see if we can get the loop we were looking to have. Let's say stage 3. And there you go. It's as simple as that. Now what I've done as well, since I used line 1, I just moved my slider all the way to the right. You'll see it stops working if you don't do that. So we need to increase the voltage. Well, it's decreasing, but then we're flipping the output. So, and then you can take that same thing and use it anywhere. You get strange effects when you have it start on a skipping node. Kind of interesting. So it's interesting when you think of things in terms of voltage rather than pitch, then you can kind of see what's going on here. So I've set the last stage to advance the sequential switch. I've still got my loop running that we programmed in before, but this stage 3 is triggered by step number 6. If you look at the lights, you can see that we've actually got 2 sets of events happening between 6 and 7 every time that we switch into stage number 3. Since this isn't polyphonic, what's happening is the voltages are getting stacked, and it gives us that high-pitched sound when it's doubled up. Pretty cool. If I were to skip that step, It's a really great trick to play with the steps that are being triggered with different voltages, just to see what they do. You can skip them, turn them to normal. I wouldn't stop because then you'll just be stuck there. Well, let's see what happens. Yeah, pretty much you just stop. But if you skip on anything that's got a trigger running into it, you can get some interesting effects. We're essentially getting a one-note sequence from row 3 because of the way the switch is set up. Alright, so lots of crazy stuff you can do with triggers and sequencing and converting triggers with your voltage processor. There's nothing you can't do with the 960 and the 2600 together. I'm really happy with it. One last thing I'll show you, which is a feature of the 960. Let me get the cables cleared up. One last thing, I'm sure there's an infinite number of things you can do. So I've still got my last stage running the shift, and it's going to go straight through. I'm just going to press play again, oscillator on. And then it's running through all 3 stages. Now there's a control switch at the bottom over here that turns on third row control of timing. And what that means is that all of the knobs on the third row that were providing pitches are now providing timing. So let me take that out of the mix here. So it's great, you can get all kinds of crazy stuff with your row 3 timing. And of course you can modulate that stuff too, I bet. Why don't we give it a try? And now you have an oscillator again. Anyway, absolutely insane what you can do with this thing. I think it works great with the 2600. Of course, you can use any one of these rows to control anything. It could be 3 different oscillators at once making chords. It could be one row controlling one oscillator, one row controlling filter frequency cutoff, and another row controlling something completely different like ring mod. So one of the great things about the way the 960 and the 962 are put together is that they're really scientifically built. I don't know how better to say it than that. They're not locked into one particular function. So if you really go back to thinking about things in terms of voltage and what voltage can do, high and low values, that will give you a lot of different things that you could do with this sequencer. I think it's a great thing to add to the setup, and I'm really happy that I did. Anyway, that's enough out of me today. I'm not too skilled with this as yet, but I just wanted to share some of the things that you can do and some of the ways that you can get it to work with your 2600. Hope you enjoy, and have a good one. Happy patching.